You know, it's that season where people are talking about and thinking about the immune system. How do we strengthen it? And with all the information out there, what do we know? I was just watching TV the other day, and even on a Cheerios commercial at the end, a young girl jumps up in the air and says, with beta-glucans. And I thought, now people are starting to relate all of the immune system and what are these beta glucans and are there better glucans out there? Well, I am honored to have our special guest speaking today because, first of all, we just love him in Zinzino. He is so wise in everything in nutrition. He loves to nerd in all of this so that the rest of us really don't need to. And he's here today to talk to us about our immune system and what we can do for ourselves and our families to have the strongest immune system. So let us all please welcome Dr. Paul Clayton. Hello, Dr. Paul.
Hey, did you just call me a nerd?
Okay. I read that, so I get to say that you nerd in the sciences so that the rest of us don't have to. Can I call
I
Dr.
I always thought of myself as more of a geek than a nerd, but okay.
Okay, we'll call it a geek, but we're saying you're nerding in this area. So, Dr. Paul, I know for me, and I have three grandchildren, and when they get started at school, and it seems like everybody gets sick all at the same time, and there's this, recurring thing that they're getting one of them sick and the next one sick, and we're coming to this where it's starting to, even the colors are beautiful, but it's starting to get chilly out there. And what can you tell us more in regards to what we can do to strengthen our immune system? And what are these beta glucans anyway?
Well, this does tend to be that time of the year when people start getting more sick, more coughs and colds and flu. And it's not because of the cold weather. It's probably because the days are getting shorter. Our vitamin D levels are going down. That hurts your immune system. And also because we're spending a little more time indoors, where we're in close proximity to other people, in conditions where it's easier to spread bacteria and viruses. But I'll talk a little bit about beta glucans because they're certainly important, very important in determining how effective your immune system is at keeping you safe. And I know that you have this breakfast cereal that's talking about containing beta glucans. That's a different kind of beta glucan. It's not the right one. Um, there's lots of different kinds of beta glucans, and the one that they are putting into the breakfast cereal are really more to do with improving the microbiota, more to do with the digestive system. And I'll talk a little bit how they're different from the beta glucans that we use to improve immunity. They're different, they're related but different. So in order to demonstrate that, let me show you some slides. I'll go through them very quickly. And after that, as usual, we'll throw everything open for questions. Now, all I've got to do is to find the slide. Oh, here it is. And make that full screen and close everything else down. And hopefully,
It's looking great, Dr. Paul.
what can you see when you look at the screen?
It says Y1316 beta glucans, and I'm looking forward to hearing that answer.
I'm glad you can see it. Oh, I can too. It's just arrived. Okay, so
Oh,
Y1316 beta glucans, and are there possibly better glucans? Well, the 1316 beta glucans are really, really important. And the whole story about beta glucans is that they used to be there. They used to be a big part of our environment. And then, for a variety of reasons, they kind of went away. And I'll talk about how that happened and why it happened. And when they left the stage, they left our immune systems naked. And what's that TV program? Naked and Afraid, something like that. Our immune systems are really not working too well as a result of this. And it's a critically important issue because right now we're seeing more and more infections. We're seeing what the CDC and other experts are calling the end of the age of antibiotics. So I'll take you quickly through some of the negative changes that we've seen. And it goes back to 1950, actually. But in 2010, there was a very major sort of problem which emerged, which was something called New Delhi metallolactamase 1. And this was a mutation that occurred. It was seen first in one strain of bacteria, then it emerged in many others, which made many bacteria, which had previously been sensitive to antibiotics in, for example, the penicillin family, suddenly they were resistant. And partly related to that, we saw this huge problem in tuberculosis. And in 2011, we saw tuberculosis becoming moderately, multiply drug resistant, then extremely drug resistant. And now we have to deal with something called totally drug resistant tuberculosis, which means that the tuberculosis that's coming back now, and it's associated with poverty. We see a lot of it in the prison system. We no longer have any drugs to treat it whatsoever. So we've gone straight back to the 19th century. We have a disease which we have been able to cure. We can't do it anymore. It's becoming, once again, lethal. There isn't very much we can do about it. CDC said in 2012, gonorrhea has become impossible to treat. All the cases that we're seeing are resistant to all the antibiotics we have. Carbapenem resistant Enterobacteriaceae, that's an important category of pathogens. The numbers of strains which are resistant increased by 500% in 5 years. And this is bad news because if you're infected by one of these, 1 in 2 of you are going to die. Another area where we are losing the battle against the bugs. And this led to the Centers for Disease Control issuing a statement saying in 2014, we are entering the post-antibiotic era. Now, that's not just a problem if you have a minor infection, you take an antibiotic and it goes away. It could be a sore throat, strep throat, for example. But it means that a lot of surgery has become much more risky. If we can't give you antibiotic cover while you're having your insides cut open for whatever reason, you're going to be very much more vulnerable to post-operative sepsis. If we can't treat that, a lot of surgery is simply going to disappear. Cosmetic surgery. I mean, at the moment, you can have get yourself tucked and trimmed in all kinds of ways, but a lot of that also depends on antibiotic usage. We don't want to. I mean, if you need life-saving surgery, you're probably going to go on and have that, whether you have an antibiotic that'll keep you healthy or not. But if it's simply an elective cosmetic procedure, would you still want to do that when the risk of having your nose altered or whatever else you're having done might be the end of your life? I think it changes very substantially the way we think about elective surgery. Then something called mobilized colistin resistance emerged. And this is a problem because colistin is a class of antibiotics known as polymyxins, and we leave those as the drugs of last resort. They're a little bit toxic, so we don't use them unless we absolutely need to. If all of the other drugs have failed, then we use them. But the problem is bacteria are becoming resistant to this class of antibiotics too. The very first plasmid, which is a little circular strand of genetic material, which gives the bacteria resistance to the polymyxins. The very first one was seen in 2015. It appeared in pigs and in humans, first of all in China. A year later, it arrived in the United States. Bacteria are no respecters of the southern border or any kind of border. They spread all over the world. And we saw it in E. coli, which is very common, in Klebsiella pneumoniae, equally common. This is a problem. It's getting very, very serious. And when you have coliform bacteria, E. coli, which is resistant to polymyxins and carbapenems, and we're seeing a lot of those now, we can't treat them. We cannot treat these conditions. And now we're seeing, as we saw with tuberculosis, Klebsiella pneumoniae, a very common cause of respiratory tract infections, they're becoming impossible to treat too. So no wonder the numbers of deaths, which are attributable to being infected by antibiotic-resistant strains of microbes, at the moment, it's about 5 million deaths worldwide. But if you look at the United Nations report projections, they're saying by 2050, it's going to be at least 50 million. And I think that's a conservative estimate. Now, in the past, you heard me talk about the way in which the non-communicable degenerative diseases are improving. Now, because we have squandered the antibiotics, we have used them too well and not wisely at all, we're losing the battle against infectious diseases also. And you can easily see a situation where life expectancy will continue to crash until we find ourselves back in some kind of dark ages. These are grim times indeed. And as if that weren't bad enough, we're seeing more and more diseases, zoonotic diseases, starting to affect humans. Now, a zoonotic disease is a disease that originally its main host is not human at all. It's some kind of animal or avian species. More and more of these are jumping ship and crossing over into the human population. I don't have time to explain exactly why this is happening. It's a complicated story, but the science has been pretty much well worked out. And we saw this with strands, species of malaria that previously had not infected humans. HIV was not originally a human virus. SARS, Hanta, Marburg, Ebola, bird flu, swine flu, monkeypox. The list is a long one. It's growing rapidly. There's been 47 new viral infections, completely new. We have not seen in humans before since 1990, and more are coming. We're also starting to see bioweapons. Now, GoFu, I don't know what you think that stands for. It stands for gain of function. And COVID-19, yep, that's a lot of evidence that that was a gain of function bioweapon that escaped from a laboratory. The work originally done in Fort Detrick in Maryland, subsequently transferred to Wuhan. It was almost certainly not a natural virus. It was almost certainly something that had been prepared in the lab, designed to infect human beings. This got out a little bit too early. So I think we need alternatives, not only because bacteria are becoming more resistant, not only because more pathogens are jumping into the human population, but also because, given the way in which the world is currently working, I think we're going to be seeing more bioweapons being developed. And of course, it's always going to be the case that some of them are going to escape the labs where they're kept because of carelessness, because sometimes human error, and who knows, sometimes done deliberately. So do we have alternatives? And the answer is we do. We could move away from magic bullets because that's what the antibiotics originally were conceived of. They were a bullet that would kill the microbe and not the man. And we could instead move to improving general immunity. And that's the philosophy not of Pasteur, who's all about magic bullets, but of another Frenchman, the Dr. Claude Bernard, who we think of as the father of physiology. Now, some people are already doing this. Some people already have stronger immune systems than we do. And if you go to places like Kinshasa or let's say upcountry Nigeria, I've been to all of these places, and you see food being served in the most unsanitary conditions. In some of the street markets, it's best to go and buy your meat and fish early in the day because then it's reasonably fresh. If you go there later in the afternoon, it smells so bad because it's been in the sun, it's rotten. So you have to cook it very carefully, and you have to use a lot of spices to cover that off flavor. And yet people eat that food and they tend not to get sick. Europeans eat that food, they will be very sick. And I've traveled with international camera crews to parts of the world like this. And you know what happens? It's always the Americans and the Scandinavians who get sick first because you have the weakest immune systems. And then the Brits get sick and the Germans and eventually the Spanish and the French. But you know what? The people who live there actually tend not to. They have stronger immune systems. And I'll go on to explain why. Same is true in India, where I've spent a lot of time. Food is stored and cooked and served in the street. And guess what? People who live there generally tend not to get food-borne infectious diseases. If you were to do that, you almost certainly would. Delhi belly is famous. People, Europeans and Americans who go to India, almost inevitably pick up some kind of food or water-acquired infection, and they have to suffer through that, and it's not very pleasant. And we're very different in the developed nations. We operate a different set of sanitary standards. We sterilize our foods and we serve them in kitchens that look like operating theaters. Well, maybe we don't all do that, but this is a kind of an idealized, sterilized Western kitchen. And this has not made us safer from infection. It's actually made us more vulnerable. And I'm going to tell you why. It's damaged our immune cells. This is an immune cell. It's a macrophage. It's one of those immune cells that's part of the innate immune system. It's in the bloodstream and it rushes all around the body, everywhere it can. It looks for pathogens. And this particular macrophage, and the picture gives you an idea of how active it is reaching out and it's gobbling up those bacteria, those little rods that are in the picture, and it eats, swallows them up, digests them, and basically it renders them harmless. This is a very, very important part of our defense system. We have other immune cells such as neutrophils that go along are an important part of this. And they're constantly roving around our body, as I said, looking for pathogens, bacteria that should not be there and killing them. One of the things they react most strongly to are actually yeasts. And these are what we call yeast cell ghosts. From Saccharomyces cerevisiae, that's the kind of yeast that we use to bake bread or to brew beer. And it used to be the case that yeast was present in the environment all around us. Now, this is what beer used to look like. Back in the day before micro and ultrafiltration, it used to contain a lot of yeast because, of course, we use these yeasts to ferment beer and wine and to make bread rise. We used to drink a lot of beta-glucans. We used to eat a lot of them. They were naturally there in our foods and in our drinks. Well, beer doesn't look like that so much anymore. It looks like this because we filtered all those beta-glucans out, all the yeast out. And by taking the yeast away, we've actually told our immune cells that when they see yeast, they wake up and they start becoming very active. We've told our immune cells, stand down. There isn't a problem. Put down your weapons, go back to the barracks and go back to sleep. And that has paradoxically made us very much more vulnerable to infection. We used to consume significant amounts of yeast and therefore beta-glucans, because they're in the cell wall of yeasts, in baked goods. But we don't eat as much bread and baked goods as we used to. We're not as physically active, or we simply don't eat as much food. And new technologies in bread production mean very often that the breads we eat today do not contain anything like the same levels of yeast and beta-glucans that they used to. And the other source of yeast, and the source that meant that we were constantly eating beta-glucans, was the low-level background contamination of yeasts that was present in almost every mouthful of food that we ate and every glass of liquid that we drank and every breath of live air that we inhaled. Yeast cells were always present. They're in the spots on the apples. And it turns out that the spots on the apples or on the pears were almost as important for us, perhaps as important for us, as the other nutrients in the fruits, because they contain beta-glucans. And then we kind of changed. We started a kind of chemical war on agriculture. We spray everything to within an inch of its life with pesticides and biocides. We sterilize the countryside, and we end up with sterilized Disney apples, which look perfect, no spots, but the beta-glucans have gone, and that is now very clearly harming us. Now, this is what a beta-glucan looks like, and for those chemists among you, you've probably realized that this is a kind of a carbohydrate. Some carbs are digestible, that add to blood sugar. They end up in glucose in the blood. Some are fermentable. Those are prebiotics. They don't work on blood sugar. Instead, they improve your microbiota. And those are the beta-glucans that are put into breakfast cereal. This is a third kind. And we call these structural carbohydrates. And you don't digest them. You don't ferment them. They're picked up in the gut. They're sampled by cells called M cells, and their M cells are constantly looking for these yeast cells. And when they see the yeast cells, they tell the immune system, wake up. We're potentially at risk. We're being invaded by microorganisms. Now, there's beta-glucans and beta-glucans. They have different structures. And it is now recognized that the different structures mean they have different effects on the immune system. So there are your 1314 beta-glucans at the top. Those are the ones you find in breakfast cereals. They don't really have much of an effect on the immune system at all. Well, there's some effect on that part of the immune system, which is in the gut, but not anywhere else in the body. Then you've got the mushroom type of beta-glucans, oyster mushrooms, for example, or shiitake or maitake. Well, they do have some effect on your immune system, but you have to remember the immune system works like a lock and a key. You need to have the right key to open the lock that activates the immune system. And the mushrooms only have an effect on the immune system because they look a little bit like the real keys, which are the 1316 beta-glucans in yeasts. in single cells, yeasts can potentially invade you and cause serious infections. So the immune system is geared up to recognizing them. Mushrooms are a kind of a poor copy of yeast. You're not in danger of being invaded or infected by mushrooms. That's not how it works. They're simply a poor copy, a second cousin to the yeasts that are potentially dangerous and that our immune system recognizes. And that is the bottom chain. They have long sidearms. So how does it work? Well, if you're unlucky enough to be invaded by a pathogen, and let's say there's been a break in the skin, a cut, the pathogen enters the tissue, one of the first things that happens is that a non-specific antibody, which is floating around in the blood, will come and stick onto that pathogen, which attracts a blood protein called IC3b. And this whole complex, the antibody, that's the Y shape, and the protein, which is the red circle, they start to break down and they release a cloud of smaller molecules, which creates what is known as a chemokine. I'm sorry about the jargon, but obviously the concentration of these little fragments is very close, very high, near to the pathogen. The further away you go, the lower the concentration is. Our immune cells have the ability to sniff out these compounds, and when they sniff them, they automatically move to higher concentrations. And in this way, they find their way to the site of the infection itself. And they'll have some effect, but they need to have another receptor activated, which is where the 1,3,1,6 beta-glucans come in. It's a dual key system. And when the immune cell is activated doubly, once by the pathogen and once by the beta-glucan, at that point, that cell is now primed. It binds to the compound on the pathogen and it initiates the kill sequence, which kills the pathogen. And it becomes so much more effective at doing that when the beta-glucans are present. I won't go into this whole diagram. It's very complicated, but this is the state of the art now. We have come to understand how the beta-glucans do this, how they improve the efficiency of the immune response, and they do so through an epigenetic effect. That is, they act on the mitochondria in your immune cells. The mitochondria are where the energy is generated in a way that gives the immune cells more energy, so they can migrate more quickly to the site of an infection. And when they get to that site, they can attack the pathogens more effectively, which means, well, let me explain this diagram to you. Here you've got a situation where you've got your immune cells, which could be macrophages or neutrophils, and they are getting to the place where the bacteria are. Now, on day 0, this is taken from someone who hasn't had any beta-glucans. 63.8% of those immune cells will start to gobble up a bacterium or two. And about a third of them, 37.3%, are highly phagocytic. That is, they're going to eat more of the bacteria. They're going to be more effective for you, help you to ward off infection more effectively. But if you've taken beta-glucans, and in this case, the experimenters gave the beta-glucans for 10 days, after 10 days, the numbers of phagocytic cells have increased from 63% to 83%, and the numbers of cells that are very aggressive, that are very good at killing off these microbes, has increased from 37 to 56%. So your immune cells are now better at getting to the site of an infection, and when they get there, they are more effective at killing those microbes. How much more effective? I think you'll be surprised. Now, I used to be the chair of one of the scientific advisory boards for Biothera. We were one of the leading companies in researching this area. We spent over $300 million of research on on the beta-glucans. Some of that was given to us by the NIH because they realized that our research had a lot of military applications. So let me explain this slide to you. We're working with animals here. At 7.5, -3, -1, at day 0, these animals are infected with anthrax. Anthrax is a killer, highly virulent microbe. And if you look at survival, at day 0, 100 of the animals are alive. But then the bacteria start to multiply inside the animal, and by about day 4, the animals start to die. And by about day 7, half of the animals are dead. What happens if we've given these animals the beta-glucans beforehand? And this is a brand of beta-glucans called Wellimmune. It is the brand that we use. In the animals that are given Wellimmune beforehand, survival is 100%. Not one of them die. And this is from a microbe that is so dangerous that it has been considered for use as a bioweapon. That is phenomenally good protection. And there's nothing else in the world that will do this. Here's another example. I'm moving from bacteria to viruses now. This is another animal experiment. I apologize for those of you who find animal experimentation offensive. I prefer to work with humans, but yeah, the ethics committees wouldn't like it if we exposed people to either to anthrax or to lethal doses of influenza virus. Now, in this experiment, we were giving the rats 10 times the LD50. The LD50 is the dose of virus which will kill half the animals. So 10 times the LD50 is going to kill all of them. At day 0, we're exposing the animals to the influenza virus. By day 9, all of them are dead. It's what you would expect. If you give these animals the beta-glucans, or you give them Wellmune, half of them survive. That is a highly, highly significant improvement in their ability to ward off the infection. You're giving them 10 times the dose that would kill half of them. You would expect all of them to die. We're saving half of them. Not everyone, but half of them. And in practical terms, that would mean that if there was a strain of very dangerous flu virus floating around in your community, either by accident or because your friendly government has released the flu virus into your population, most of you would die unless you had been taking Wellmune, in which case the vast majority of you would survive. No vaccinations needed, no mRNA clot shots needed. This is entirely safe and natural and a much more effective approach. Are there human data? I hear you ask. And yes, there are. Very interesting clinical study. This was done in human patients who were being treated for abdominal problems. They were being given colorectal surgery. This is a highly, I would say, contaminated form of surgery. The large intestine is full of microbes. Every time you do surgery on that tract, you're releasing very large numbers of microbes into the abdominal space, no matter how careful you are. There is a high level of post-operative infection, which is kept under control with antibiotics, except many of those antibiotics do not work so effectively anymore. If the patients were given beta-glucans before the surgery, you can see that the post-operative infection rate shifted. It dropped down from 1 in 4, and at a dose of 1 milligram of beta-glucan per kilogram body weight of the patients, there was effectively almost 100% resistance to infection. No cases of post-operative sepsis whatsoever. If any of you are unlucky enough to have to go into the hospital for elective surgery, I would very strongly recommend that you take beta-glucans before you go in. That's probably the best, most effective insurance policy that you could possibly adopt. And it turns out that the beta-glucans have a relevance to allergy as well, because they're mostly acting on the innate immune system, but the innate immune system and the adaptive immune system, which is involved in allergy, they talk to each other. And they talk to each other at the level of what we call, it's a cell type called the mucosal dendrocyte. You don't need to know the jargon. It's a kind of a macrophage. Now that's an innate immune cell. But if you're living a traditional lifestyle, which contains lots of beta-glucans, the macrophages in your innate immune system are having a conversation with T helper cells, which are part of the adaptive immune system. And you start off with T helper cells that are called naive or Th0 cells. If you have beta-glucans in the vicinity, in your environment, inside your system, the macrophages tell your T helper cells, become Th1. Th1 cells are going to help you to resist infection. So that's a good thing. That's how we used to be until the beta-glucans were removed. Now the macrophages are no longer giving those instructions to the naive T helper cells, and instead they become Th2 cells, and the Th2 cells are profoundly involved in allergy. And this shift from Th1 to Th2, because the beta-glucans have gone, is one of the main factors that has led to the huge increase in allergy that we now see, not just in the classrooms at school, but all around us. The answer is simple: put the beta-glucans back into the system and restore immunological normality, which is what we do with Protect, which is just pure beta-glucans. It's Wellmune, the kind that I've talked about, that we did in our studies. And it's a smaller component, but still a hugely significant component in the much more complex and effective formulation, which we call extend. So in a word, or in, I don't know, maybe a couple of thousand words, that's what the beta-glucans are, and that's what they can achieve. These are very, very potent biological molecules indeed. So having said that, let me stop the share at this point and throw the event open for questions.
Thank you so much, Dr. Paul. There is so much in there, and it gets people excited about what we really can do ourselves to really build up that strength again. And like you said, it gives, it gives more energy to the right areas of the mitochondria. So exciting. Okay, I do have a question here in the chat um, that are asking about the forever chemicals,
Mm.
like the different microplastics, and how are we covered from the health protocol, or at least how can you ensure that we're not getting more of microplast into our bodies? Is there anything that the Sensino supplements are doing in regards to helping with other outside things?
Well, Julio, thank you for that question. But what we're doing with certainly with beta glucans, we're targeting microbes, not microplastics. Now, microplastics are very hard to avoid because they're everywhere now, both microplastics and, of course, plasticizers. Uh, we have not been particularly careful in the way that we use and then discard plastics. And you now find them not only widely distributed in the environment, but you find them in almost every biological and physiological compartment in the body. They're present in our bloodstreams. You find them in the placenta. You find them in the brain. They're everywhere. And they're probably not doing us very much good. The Zinzino Health Protocol is not designed to protect against microplastics because the solution to this particular problem is not something that we can control. What we have to do is adopt better usage and environmental practice. At the moment, I think only 5% of plastics are recycled. 95% of them end up in the waterways and in landfills, and they're constantly breaking down, leaching into various life forms at the big bottom of the terrestrial and the marine food chains, and then eventually coming to us. And they're in the air, they're falling in the rain, they're in the groundwater. It's estimated, and probably you've heard this before, that each of us consumes enough microplastics in the year. It's about the equivalent of a credit card, maybe more. This is certainly not good for us. We don't have a specific antidote. We know that one of the things that these microplastics do is that they do seem to create or upregulate various inflammatory responses. And of course, those we can reduce and modify and modulate. But I think the microplastics are doing other things as well. We can't cope with all of that. We need improved environmental policies to cover better usage and better cleaning up and better recycling of the plastics that have now become so universal. I'm sorry, Julio, that might not be the answer you want, but this is a huge, wide world problem. We only have access to a small part of it.
Wonderful. Well, thank you, Dr. Paul. Anna's asking, should we be taking Protect every day? Should we be taking one or two? Should we be adding more if we have different conditions? What should we be doing? Or maybe in the seasons? Or how would you recommend?
Well, I think that if you have a seasonal allergy, and not all allergies are seasonal, then you can act accordingly. So you can start taking beta-glucans at the start of the season and continue to take them until the end. If you're more concerned, if you're going to go into hospital for elective surgery, for heaven's sake, take the beta-glucans for a few days before you go in and continue with the beta-glucans until you've healed. If you have a non-seasonal allergy or you simply want to keep your immune system in good shape on a long-term basis, then make it part of your lifestyle. Consume beta-glucans every day. That's what we used to do until various changes in agricultural and food production and alcohol filtering processes took them out of the food chain. when we take beta-glucans, it's not as if we're taking something new. We're actually putting something back into the system that always used to be there. We're restoring immunological normality.
Okay. So I don't always like to get into specific cases. So I'm going to ask this more generally because Roberta is asking when kids nowadays, you see a 19-year-old, he was healthy and a professional basketball type player. And then all of a sudden you have these antibodies that usually fight infection and it starts to attack the system. Is that tied into the immune system or is that something separate or what can we be doing for that?
Okay, well, that sounds to me as if it's a kind of an autoimmune condition. There isn't a diagnosis, that specific diagnosis mentioned in the chat box, but it's one of it's a relatively small number of conditions that it could be. Now, the numbers of autoimmune diseases have increased dramatically. When I was at medical school in 1968, there were maybe a dozen, maybe a few more autoimmune diseases, and they were uncommon conditions. Now they're one of the most prevalent conditions of all, and we've seen them not only increase in frequency, we've seen the emergence of a whole new families of autoimmune diseases. So clearly, something is wrong about the way in which we live, which has made these much more important. One of the things that has made them more important is increasing dysbiosis. If you have the wrong bacteria in the colon, you end up with what we know as leaky gut. Bacteria in the gut are able to escape. They get into the blood system, they get into other tissues and hide. This has now been identified as an important cause of what we used to think of as being autoimmune disease. It is possible that the effective removal of 1316 beta-glucans from our personal environments has made a contribution to this, and various other factors have played into it as well. So let me just quickly say that protect and extend are not the answers to this boy's problem. He has an autoimmune condition, I'm almost certain of that from the description, which is causing intense focal chronic inflammatory stress. And the important thing to do here is to alleviate that. And if you can prevent that chronic inflammatory stress and damp it, you're going to reduce the amount of damage to the end organ, which in this case is the uh, neuronal muscular interface. So we want to cut that chronic inflammatory stress down. We can use other tools to do that. And I think that it may be possible, I hope it's possible, to stabilize this boy's condition and perhaps even permit a degree of recovery. I'm not going to make false promises and give you false hope. It's impossible to say because I know nothing about this individual case, but I've seen similar cases where we've seen a great deal of restoration of function, in some cases, effectively complete restoration.
I love that. We're making a difference and an impact in the world. So someone is asking, because you mentioned both the protect and the extend, if you're really wanting to get healthy or have that immune system, can you be taking both? And is one better than the other for the immune system?
Uh, okay, the immune system is, oh God, it's an extraordinarily complex system, full of checks and balances, and redundancy and feedback cycles and buffering systems. It's extremely complicated. I don't pretend to understand all of it. I'm not sure even the most advanced immunologists understand its totality. It's a level of complexity that is bewildering. Uh, the beta glucans are certainly extremely important in enhancing the functionality of the innate immune system. But I'll be more specific. It enhances the functioning of the cells, the cellular components of the innate immune system. And I mentioned macrophages, neutrophils, there are others. But there's also other parts of the innate immune system which are not cellular, they're humoral. So enzymes such as lactoperoxidase is one, and there's proteins, lactoferrin, all kinds of other components. We can enhance the functioning of lactoperoxidase as well. We use a different set of tools to do that. And what we find is that once you've upregulated both the cellular components and the enzyme or the humoral components, I won't say you've become bulletproof, but at that point, it's very difficult for you to develop a clinical infection. And if you do have one, it's most likely going to go away pretty quickly.
Okay.
Now, the immune system also requires, for its overall functioning, a very large number of other micro, and I would add phytonutrients. And a lot of those have been packed into Extend. So Extend is a much more extensive, as the name implies, product. It provides somewhat broader support, but it also has the beta-glucans in it. So it's more expensive accordingly. The Protect is the less expensive version. And it means that the beta glucans can be made available at a lower cost and more people can buy into them. And I think that's important.
I like that. Thank you. Dr. Paul, Magdalena is asking, we hear more of these heavy metals that are affecting our body, affecting our brain.
Mhm.
Is that affecting immune system? Is there something we can do with that? It just,
Oh, good Lord. Well, this is opening up another can of worms. Okay, there's a whole range of heavy metals, so-called, and not all of them are heavy. Um, for those of you who are interested, I have a blog, which is, and I'm going to type the address of the blog into the chat box. drpaulclayton.eu. And if anyone has the time and the inclination to visit that blog site, type in heavy metals, and it will take you to a post that I wrote specifically on this subject, where I look at a whole range of ways in which we can become exposed to heavy metals, and more importantly, ways in which we can reduce the adverse effects that they have on us.
okay. Wonderful. I'm going to ask one last question. So, when we're talking immune and we're talking extend and our protect, now is the rest of the health protocol, would you recommend taking the health protocol, all of it for the best immune system, or does it matter for that?
Yes, most definitely, because the xenobiotic rectifies the situation in the large intestine, and that has a positive effect on what is known as the GALT, which is the gut-associated lymphoid tissue, which is a different part of the immune system. I mean, all of the different parts are integrated, obviously, but if you want to activate or upregulate the functioning of the GALT, then for that, you need the 1314 beta-glucans that we put into xenobiotic. It's probably an indirect mechanism. The prebiotics lead to an increase in the growth of the probiotic species, lactobacilli and bifidobacteria, Akkermansia, mucinifera, and a bunch of others. And what they do is they actually talk to the immune cells in and around the gastrointestinal tract and modify them and modulate them in a positive way. So, as I said, the immune system is really complex. Honestly, I don't pretend to understand all of it. I just understand enough of it to be dangerous. And if you want to support its functioning and make it as effective as you possibly can, I would recommend using the entirety of the health protocol.
Wonderful. Well, Dr. Paul, we thank you for taking time out of your schedule here on Saturday, and we think this subject is so important, and we want to have a very strong immune system for ourselves and our families. So thank you for taking the time here. I will allow everyone to unmute and say thank you to Dr. Paul. Thank you all for joining, and Dr. Paul, thank you again.